Okay, I've got 1:30 Central, so we'll go ahead and get started. Hello, everyone. My name is Alexa Galley, and I'm the Vice Program Chair for this year's Virtual Cohesion Conference. We're glad to have you join us today, and we hope you've been having a great week. The session that you're in right now is called Containerizing a Banner Application, as you can see from your screen. If you have any questions during this session, please go ahead and use the Q&A feature. I'd like you to introduce you today to our presenter, Robert, with David Kent Consulting. And Robert, I'll hand it over to you. And if you need anything, I'll be here in the background.
Okay, thank you. So we'll get going here. This is going to be a little bit of a fun time doing this with a panelist version. I will have an eye on Tom a little bit, and we'll try to watch the questions. There are about 4 or 5 little mini sections to this presentation. We'll stop for a quick catch up there in case somebody has any questions, and a formal Q&A at the end. So I'll do my best to keep an eye on things as we go forward. And Tom's my little helper bot, so we'll go. First off, I'd like to thank people for showing up today. This is Containerizing a Banner Application. This is a small survey style talk on some of the fundamentals of stuff like that. Quick introduction is we're going to talk about Application Navigator and Docker and Linux today, and how to containerize a basic banner application. We'll construct a Docker file, which is used to build the actual container and explain its components. And then we'll actually build that container and set it up and run. And then we'll talk a little bit at the end about ESM and how it can be used to drive this process as well. As mentioned, I'm your presenter, Robert Landsberger. Most people know me as Rel. I just recently got my CISSPs. That's something I'm kind of proud of. I've been with David Kent for going on 8 or 9 years now. I'm currently a senior solutions architect, but my background has been in higher ed for almost 30 years. I like to focus on identity management, data center management, system administration. I'm a geek by heart. Right now, cloud design and architecture is something I've been playing a lot with, along with virtualization and now containerization with both Docker and with a focus on moving this streamline into Kubernetes with currently OCI cloud stuff and networking, load balancer, all that fun stuff. So today's talk is brought to you by David Kent Consulting, and we are a group of experienced Banner, Oracle, and cloud professionals who provide functional and technical services to higher education, and our goal is to help you get the highest possible return out of your Banner investment. Okay. Now, on to the talk. The agenda will talk a little bit about comparison between a regular traditional application server and what it means to containerize it, go over the basics of containers, how they interact a little bit, short tutorial into Docker, then we'll get into the actual containerization of an application, and then wrap it up with ESM integration. Okay. First part here is comparisons. This is probably the simplest of the slides we have here. Basically, an application server running an OS and an application container, as I call it, basically have a lot of the same components. They both run Tomcat with Java, these for Banner. They have a WAR file that makes them do their magic. There's app nav, admin pages, all the fun stuff. The configurations primarily is server.xml and context.xml, which tell Tomcat how to interact with the database, how to interact with web requests. Is it doing SSL offloading? Does it have to, what's its proxy server name? So it knows how to process the web requests it gets and how to generate the pages on the outbound. And about the only difference between these two constructs is what they run on. In this case, the application server we're used to dealing with runs on like Red Hat Linux, OEL Linux these days. Not so much Windows anymore, but it can. And then where the container runs its own little flavor of Linux called Nginx. It is a very small, purpose-built kind of Linux for this containerization. So it should not be, hopefully not too many questions on that. Now, after this next section, we'll stop and see if there's any questions. Containers. Okay. Containers are kind of like small virtual machines. They are meant to be stateless, meaning that once you shut it down, it reverts back to its original state. So it's like always in a perpetual snapshot. These images are stored in registries, and the registry is where you fire up a Docker image or Docker container, it pulls out of the registry and runs it. The registry can contain multiple images, both based on the name of the image as well as a tag. And a tag is kind of meant to be a versioning construct. You can tag something with the date, you can tag it with its AppNav 3.1.1, 3.3, 3.02, or you can just say it's the latest version of it. And latest is a special construct for Docker to use. If you don't specify which version, it always fires up the latest. And the nice thing about containers is they're portable between registries and platforms, meaning that I can take a image, a Docker container I built in my Windows box with a couple tags, push it off to a repository that sits out in Oracle Cloud or up to the Docker Hub or even to my house. The containers operate independent of the running platform, meaning that the same container will run both Windows, Linux, Red Hat Linux, OEL Linux, and it contains all the stuff it needs to run. So when the person who built the container says it needs Tomcat, there's Tomcat in there. If it needs Java, there's Java in there. I'm finding that vendors are actually distributing containers. I had one client where the container contains MySQL built into it, a couple other stuff, and actually is a fairly big application, but it has all of its dependencies baked into it. And that makes them more resilient and not adversely impacted by like host OS patching. If you change the version of Java on the Red Hat box, is it going to break my Tomcat container? Nope. If a file gets messed up on or corrupted on the host OS, is it going to cause a problem there? Nope. If I decide to move from VMware to OCI from my Docker and inside a Red Hat Linux on a VM box, it won't care. It's still inside Docker. Moving forward, Docker. So we talked about a container being a small environment that runs an application. Docker is where that environment runs on. It's an environment that we use to build the containers. We run the containers in it. And by default, Docker will have a local image registry that is configured. What happens is when I build a container, it'll push or pull it from that registry. If it needs another resource, it will pull it from the web and put it in that registry. And like I said, I can also then tag something to go to an external registry, and Docker will take care of that as well. It also provides access to the container itself from a console perspective, meaning that I can run a Docker command and connect up to a running container and actually look at logs, look to see how the file system is full, or if it's not full, if it has certain processes running. Not that that's all needed, but it's there as a handy way of debugging kind of things. Or if you want to make sure you built your container right, you can build it, fire it up, go look inside of it, see if things make sense. Docker networking can be a little bit of a challenge. A container is a small operating system that is running. And when an application fires up like Tomcat, it listens on a port. Traditionally, Tomcat will listen on port 8080. Now, that container is contained within itself. I think it's a bad way to say it, but it's its own little entity. In order for it to speak to someone on the outside, Docker has to forward ports from the outside of the container to the inside of the container. And we'll talk a little bit about that. So the Docker, when you fire it up, you can tell it that the Red Hat Linux box that's running this, if it gets a request on port 8080, forward it inside this container on port 8080. If it gets a request on port 8090, forward it to port 8080 inside the container. So the container doesn't have to change the port it's listening on. You can use the same container and just do a different port mapping when you start it up. So that leads us to the point that the containers don't have external IP addresses. They share the same IP address of the Red Hat box. I'm going to use Red Hat from now on. The Red Hat box that's running the container. It also uses the same port space so that you can't fire up two containers and have them try to listen to the same port that the Red Hat box is running them on. So they have to be different ports on the outside of the container. So it can forward to ports on the inside of the container. That will be something that playing with and getting a little more experience and starting and stopping the containers will make a little more clear. But when a container is running, it is pretty much like any other process on that box. It is limited to unique ports it has to have, but it does its own internal stuff to allow you to not have to rebuild the inside just to make the outside look different. And that's one of the neat things about containers. The repository I talked about, this is the repository. It contains standalone containers, or if a container is being used to build another container, i.e. Nginx, you'll see it along with the container you built in the repository. It will also prevent you from removing a container that another one is dependent on without telling it to force it. And if you force it, it will remove the dependency and maybe not the container you really wanted to remove as well. So do not force things unless you've taken some time to think about the repercussions. But the nice thing is their containers can be rebuilt again. They are portable and disposable, meaning that whatever in a repository was been built from some other source code stuff. So the whole infrastructure as code kind of mentality follows here, that containers are meant to be portable, disposable, and immutable. I mean, I can just make another one. Okay, containerization. Before we can talk about full containerization, I need to talk a little bit about the directory structure that I use when building banner containers. Because Docker has to can only pull files from inside a root path that you specify, and you really don't want to specify / of the machine, I decided to come up with its own little directory structure for deployment building. So along the whole UO1 construct, I made a directory called UO1 ban deploy environment. And inside there, I made 4 subdirectories, one called app, which is the place that traditionally where ESM would land the final war files in that tree. We'll go over that in a minute. Docker directory contains the build file and the build script. We'll talk about those in a minute. ESM share is your traditional mount that comes off your job sub box with a twist of lemon, meaning that I mount the share off the job sub box as a subdirectory inside the mount directory. And then for the ESM share environment, in this case cohesion, I make a symbolic link from ESM share cohesion to mount job sub server mount / cohesion. This method allows me to have multiple job sub servers mounted on this single Tomcat host and handle multiple environments coming from multiple job sub servers. Because they'll all look the same. They'll all look like UO1 ban deployment ESM share or ESM share / prod / devil / preprod, even if devil, preprod, and prod have different job sub hosts. They would be mounted separately inside of MNT. This allowed me to have one mount from each job sub host to represent multiple environments. So we'll see how these files come together in a minute, but inside of the app directory, as I mentioned, I have my banner environment name, in this case, cohesion, and then admin and the admin conf directory, which has the files I said that makes the Tomcat special for where the database connections are and how to interact with like the load balancers and stuff like that. And then we have the WAR files. These WAR files were what were deployed here. Okay, I see the question from Elwin to all panelists. Where does the Tomcat bin set in? You would put, I have not needed to use that in the past, but I'll show you where you would add that to this process. So I will make a note to touch on that. What I would do is make another directory in here, and this parallel to the web app and conf called bin, and put your setup there if it's unique to each environment. And then we'd add one more line to the build file. The Docker directory contains the build script and the actual build, the Docker, what they call Docker file, which actually is the script to build the Docker container itself. And the cohesion build script listed here is, oops, that's not meant to. Listed here is meant to take and actually construct the container. Okay, so the containerization process is pretty straightforward. We create our Docker file, next slide, and then we run our build script, slide after that. We execute it 2-3 more slides later, and then we can start the container up. Okay. So the Docker file is basically a set of instructions or script that allows you to take images and transform them into more specialized images and turn that into a container that you can then run. Some of the items in there will be the from command, the arg, which you'll see how I pass in to know which environment we're building for. As the image is built or container is built, it actually is started up because it's a Linux box, and then you can run commands on it. You can add in files from your UO1 ban deploy env or your Docker build tree. We can then set some labels up if we want to do some tagging with like Kubernetes or other stuff like that where it needs to know how the image was built. The expose is kind of like your IP tables where it says which we're going to allow to get the outside. It's Tomcat, so always expose 8080. And then after the container starts up, what command do we need to run to actually make it do work? And we'll go over that right now. So this is a simple Docker file. This is sufficient enough to build a Tomcat container that runs Application Navigator with some of your basic Tomcat configurations. And from this, if you do super special Tomcat stuff, you should be able to modify this pretty straightforward. So starting at the top, the nice thing about this is that we are going to tell it to build from a Docker Hub Tomcat version 8.5.53 that already has JDK 8 and OpenJDK already baked in. So if we want to move Tomcat versions, we can change the Tomcat version here, rebuild our container, and we're all set. We don't have to install Tomcat at the OS. We don't have to download and install a special version of our container. We just kind of reference a reference image here. That's not to say that if you wanted to, not sure why, you could just do from Nginx and then build Tomcat or download a, do wget and other kinds of stuff, because as we see in the middle here, there's a run command, which allows me to run a Linux command. This version of Tomcat has the manager app already magically disabled because it just puts it into web apps dist. So all the ones that you would normally find in your web apps directory are moved out of the way. In this particular instance, we wanted the manager app added back in. So as an example, we just moved user local Tomcat web apps dist that's inside the container to just web apps. Now we needed to pull some files into this container. So the Docker files lib, which contains OJDB6 or 8 and the xdb6.jar files. We add those files from the external OS into our container and put them in user local Tomcat lib. And then the next one, we actually copy in the app. In this case, bannav gets set to cohesion, banserv got set to appnav, comp star. So this pulls in the server.xml and the context.xml internal to this. If you had a special setm.sh you wanted to pull in and it was unique to each environment, you would add it. You'd add another line here. It might be add appnav bannav banserv /bin/star to use local Tomcat bin. Or if it was the same setenv for all your environments, you might make another thing inside Docker files bin and put that there and copy that to user local Tomcat bin. It all depends on how you want to craft your Tomcat. I didn't have a need to do the setem.sh because I wasn't messing with the Catalina home or base or Java. It just started up. So it may or may not be needed in this case where you're running your own dedicated version of Tomcat in your own dedicated OS. Okay. Next up, in this case, we did not do SSL offloading, so we needed the certs internal. So we copied in cert files from local OS into user local share. And then we needed to run a command in order to actually import those certs into the CA certs file. And then next up, we set the time zone to Chicago. We exposed out port 8080, and then we said, when you do this, just run catalina.sh to start up. This is the script that I used to build a container. This will also be what's called from ESM when it actually goes to build the container on the fly. So we set up our Docker home at the very top here. This if target dir is meant to put some default values in play in case we're not running from ESM, like what the name of the app serve was and what the application we're building was, and where the target dir was. So we understand how to, we can simulate an ESM call when I'm just running it by hand on the Tomcat build host. Some of the sed magic here is I need to take and get a date tag I want to tag my image with. And then I go ahead and build my tag, which in this one line here is the environment name, which might be cohesion /appnav, and then colon the date. Do a little more sed cleanup to remove spaces and turn into underscores and something like that. Print out the variables so I can see what they look like. And then the last line here, Docker build. It says when we're done with this container, go ahead and tag it with the build tag. We're going to pass in arguments. The banserv is going to be appserv name, which would be like appnav or admin. The build argument for the banner environment would be cohesion. And then we're going to call it with dockerfile.cohesion and specify the Docker home as the root of the build tree. So this is the magic oven that bakes the stuff. Next slide here, we can see that it starts up a second. And if we go through it, it actually shows the 16 steps, what the step is and kind of the resulting intermediate image. And I was able to pull some stuff from the cache, add the labels, and goes through and moves his files out of the way. It adds in the config files, adds in the war files, adds in the certificates. And when it's all done, the very bottom here, it tagged it cohesion /appnav and the date string. We've built a container and it's ready to be started up. Okay. We do a Docker image ls. We can see that the image is in our repository. In this case, I ran the build script twice, relatively close to each other, 16 minutes before I made the slide. And the tags are different because they're built at different times, but the image ID is the same, which means those are both the same image. There's nothing different between those two containers. They were just built at different times. If you wanted to clean up some stuff, you could clean up one of them because the other one is the same. But you also might see the same image ID if you had a tag of latest and the tag for the date. The next command is our Docker run command. This actually will start up the container. The -D says detach it, run as a daemon in the background. And then we're going to take port 8080 of our Red Hat box and attach it to port 8080 inside the container. And then the container we want to run is cohesion appnav, and then that crazy date string. Okay. It gives us a GUID back for the container when it's running. The Docker image that's running, we can do a PS. We can see that it was started 5 seconds ago. Docker will generate a random name for it, which is usually some adjective and of noun. So we got suspicious Vasquera, probably not the best random name for a demo, but I didn't realize it until it's too late. But now I can do a Docker exec interact with a tag, and I give the tag name suspicious, Braska, and bash. And now the bottom part of the slide shows me actually kind of SSH as you were connected up to the console, actually logged into the container. I can do it, I'm actually already in user local Tomcat. I can do an LS of web apps, that kind of looks familiar. If I look in web apps on the first iteration, I can see that the WAR files are there. It hasn't been running long because they haven't started to expand them, but on the second iteration of web apps, I can see that the Banner admin page is going and the WAR file is there, and the bottom one has Banner help expanded and application navigators expanded, and we're all set. Because as containers up and running, we can look at logs. I can do a tail of the logs, the last couple lines. I can see that, oh, Tomcat's fully up and running now. It's been almost 3 minutes. That's no different because we're running admin pages, appnav, and on the same Tomcat container. And then just to show that it's working, I can do a curl to localhost, which is the Red Hat box, port 8080 / application navigator, and I get back the redirect to seamless. So it actually is interacting with the right WAR file inside that container that's running on the Red Hat box. So I can just, to stop it, I just basically do a Docker PS, find the one I want. And one thing to note here is you actually can see that if you started at multiple containers and you didn't know which one was which for port forwarding, it actually does tell you that port 8080 on this IP address, or basically all IP addresses, all interfaces on that box go to port 8080 internal. This does mean that when you fire up the port forwarding, you actually can bind the container to an IP interface on the Red Hat box and actually do some more network magic if you're so inclined. So when I'm done, I can kill it off, Docker kill, and the PS shows that it's gone. So any questions at this point except for the Kubernetes question, which I will still get to, I promise. ESM integrations. So to get ESM ready for integration, we need to make sure that the Tomcat user is a member of the Docker group. We want to restart the Jenkins process so that it becomes running as a member of the Docker group. And then in this case, you take this knowledge and apply it to your environment. I'm running everything intentionally through a single Tomcat surrogate, meaning that I'm building all my containers on this one machine, and the funny part is in the end, it never runs Tomcat. They'll get pushed off to Kubernetes downstream from here. But if you're deploying out to your Tomcat box and then you want to start it up there, that's great. The way you make it happen automatically, or at least build the container automatically, is first you need to set the staging path up so that the machine that you're building this on understands where to find the WAR files. And here, this looks very much like the path I said, where the UO1, ban, deploy env, ESM share cohesion exist. And then after that, the one thing is you go into and set up your app server names, or admin, those match to those pathing we talked about kind of down here at the bottom, where your Catalina web path is the same name as one of your app server paths. And they're all built on the same host. In this case, my cohesion build host, they all on port 8080. Here, this particular application is behind a load balancer. That's why we're 443 on the admin port, the application port, but 8080 on the admin port. And actually, where we're using this right now, every environment points to, it's like 3+ environments all point to the same box. Then to make ESM work, you basically go into the band9 word directory on each environment's job sub box in that tree. You're going to make a directory called deploy scripts, and then slash the application name, in this case, application navigator or banner admin or whatever ESM calls the application for deployment. You just need to make a small script file that has basically one line in it. It just runs UO1 ban deployment Docker, in this case, my cohesion build script. And I redirect it to a log file that's based on process ID for output. So if I go on to, if I have a problem with my build, it fails, I can go on to the build box, the Tomcat Red Hat box, look in /temp and actually read the output of my Docker build. So it is saved there. And then make sure that you have the build script available on your Tomcat host. And that is, so then next time you do a deployment, step 2 of your deployment will take a lot longer because it has to build the container. It takes a little bit longer in mine because part of that build script actually pushes it off into Oracle Cloud so that we can pick it up in Kubernetes down the road. So this shows how to build the containers for Banner, and you can run these locally, pretty much almost with no adjustment to this, a little bit of learning. But the framework here is also for my application designed to push it further down the road out to Kubernetes. So I have a very structured way to keep track of it all. So in summary, the containers are purpose-built application environments with an OS. Doesn't matter if it's Red Hat or Nginx, but in this case it's Nginx. We run our virtualization platform is Docker. We kind of run things through there. Containerization is the actual standardized building of these application containers. So we take our Docker file or script and we build it. And in this case, we'll pull new WAR files in from ESM if needed. And then we can use ESM to automate the rollout of our new containers if there's a new application to build. So at this point, I will open it to questions on, we have 15 minutes or 14 before it auto kills us. Okay.
Rel, why don't you go ahead and start with the question from Rodolfo Roman?
Okay. So first question was, was how does orchestration like Kubernetes, how do you handle multiple nodes to handle load, and do you use Docker Compose? Right now, Kubernetes, in order to do the multiple nodes, I guess, so let me get straight. In Kubernetes, node is like a Red Hat box. A pod is the actual container that is being run. So Kubernetes handles multiple, you can have multiple nodes and run multiple pods on those nodes to give you your capacity. And then you would use Kubernetes load balancer service to do the automatic communication between the different pods running the same image in the nodes. I didn't want to answer that with a lot of acronyms, but that's the gist of it, and I do not use Docker Compose. How do you handle multiple nodes? Handle load. We are to also handle resiliency. Right now, we're also using a load balancer front end to the actual Kubernetes stack inside OCI to actually do service to the different nodes, and the actual internal Kubernetes load balancer handles the node to pod communication. A lot of whiteboards, kind of hard to explain, but those are the gist. Okay. Next up, where you handle Java ops. Haven't had to set them. Haven't hit performance issues at the moment. For this case, I would follow the same ideas, put them into a custom setm.sh, put the setm.sh into either Docker files bin and put that into the container, or if you want it special for each container, then you'd have to make a UO1 banner deploy env app slash banner environment name slash app serve name slash bin, just copy those into there. Okay.
Looks like Kyle Hunt has a couple of questions.
Okay, and then I have one in the chat too as well that came in. Okay, so Kyle, how does Docker handle sticky connections? We found that we need to have our load balance use sticky connections. VPD environment, is there something similar in the Docker ecosystem? When running Docker in this method, it's actually, they're almost like monolithic Tomcat boxes running on the Red Hat box. So there's the stickiness will be handled the same way if you had multiple Tomcats running on the same box. So however you're handling that, it would be the same way you'd have to handle for this. It gets different when you move to Kubernetes, which has its own load balancing going on. Next up, Kyle, would be we have a VM, with a VM setup, we archive the logs to a folder upon Tomcat restart. Does the Docker facilitate this kind of log retention? In this case, as shown here, no. But with Docker, you can mount up volumes when it starts up. So you could either do it when you did the Docker run, you can present a place where you want the logs to be preserved, and the container would just mount that up as like UO1 inside Docker container, like user local Tomcat -logs could be mapped to a file system outside your container through NFS that actually has the log facilitation for retention. So the container itself, once it shuts down, it loses everything it knows. But this would also be a method where you can mount an external file system to be able to do like Docker or images for GUA image. So you can actually reference, you could take and have user local Tomcat GUA image be amount of /UO1 images, and then have the container server.xml reference those internal pathing as well. So you can get you do have access to the outside file systems if you want, but it has to be available on the machine that is running the container. So if you try to do that in Kubernetes, you got to probably do NFS and actually mount it as a volume as opposed to a local file system thing. There is methods to actually save the data that way. Next up.
Question from Joshua Morass about
Yes.
Keeping track of ports.
Thank you for the comments. And in case I missed this, how do you keep track of ports? Ports are your responsibility when you fire up the Docker container. Again, it's no different than a one-to-one startup in the OS level when you're using Docker. With Kubernetes, it depends on how, when you do the services, you can actually hard code through the YAML files I use. I actually will set the port for each application at that point, but it is still a manual process to understand that this particular port, like there was a presentation on Wednesday where they took in each digit represented something different on a port. That still has to happen a little bit. You have to keep track of that. Internally, it's on port 8080, it doesn't care, but when you fire it up, you have to care, because either your load balancer has to know which port on which service deals with which application, or your users have to know. So we really can't get around from that. Do you put your load balancer in Docker as well? In the one application we're doing we're using a monolithic VM that is that because we don't want to lose state, and it actually is meant to be more not as disposable as a container is. So you can, as long as you don't store your configuration for your load balancer inside of there. Okay. So how many users do you handle? Okay, let me see. How do you stop and start? You would stop and start the WAR file inside a container just like you'd have to be logged into the box. You would do the docker exec and then run whatever command you would to start and stop. They're disposable. I don't like it. I just restarted the actual container itself and not the WAR file inside the container. How many users do you handle? The containers that we're running are beefy, but not overpowered. I mean, I don't know the real answer at the moment yet. We haven't went through a registration set with this yet. But before we get there, one of the things I also do is JMeter testing for registration load balancing. So we'll run through that before we actually turn this fully loose on a full registration cycle. Have to use Java ops for log4. Again, whatever you're doing for your environment variables in, okay, so I did the anonymous attendee, Elwin, whatever we do, yeah, whatever you're doing now to set those things, you can adapt it to this process and they'll be nicely documented and scriptable. The Tomcat you get is a regular out-of-the-box Tomcat. So unless, I believe the talks I've seen, and also what we do is we replace the files en masse. Again, the thing you have to be cautious of is your server XML changes, settings inside of it. Okay. RVMs use 4 gig max per Tomcat instance, and we are stacking about 7 instances, 20 gig max. How many? We're able to run banner registration. Again, as I mentioned that, we're in the process, we'll load test that before it goes. The containers, when we were firing up AppNav and Ab, they were loading up in under a minute each. So they're pretty good sized VMs and OCI that we're using for the containers. And then are you aware of some banner web applications that cannot be containerized? We've done all the standard ones that you would push out to an app server. So the answer currently is no, because the nice thing about ESM with pushing out through the app server model is that it builds the WAR file, puts the WAR file up there. The WAR file has everything it needs. It's grabbed in the EIS it's grabbed in the like application navigator Groovy file, whatever that pathing is, and kind of baked it all together. Oh, sorry, I didn't push this button first. What can't be containerized? There we go. Anything goes out through ESM through AppNav. Sorry, anything goes out through ESM Tomcat to an application server should be okay to containerize. Okay. Thank you, and we have 1 minute left. My contact information is here. Feel free to reach out. And thank you. I think we're about done.
Thank you very much. Appreciate your time.
Okay, thank you, and send me a mail. I'd love to chat, and reach out to me on Telegram. So, thank you.